Hello everyone and welcome to my YouTube channel. If you're new here and you have anything to do with civil engineering, just subscribe to my channel. It will be a great help. I always upload advices and tips about civil engineering and special tutorials. So last time I uploaded a tutorial about a rigid foundation. So it was tutorial 1 in Plaxis tutorial book. It was a rigid foundation. Now we're gonna go to case B. What's the main difference between the rigid foundation and the raft foundation? So the first is a rigid foundation and we have a uniformly distributed stress under the foundation. So now we're gonna draw a raft foundation where there will be a column, two walls, and some load on the column, the wall, and uniformly distributed on the raft. So as you know, if you watched the last tutorial, it's a quarter of a building. If you haven't, you can go and watch the first tutorial I made. So let's start. We're gonna save this file, save as, we're gonna name it foundation case B. Okay, so let's start. It's 50 centimeter concrete floor stiffened by concrete beams. So now we saved it as concrete as case B. So we're gonna go to structure. Let's see what the tutorial say. First of all, we're gonna change the material. It says that we should open the material, change the clay. We're gonna put the Young's modulus to 5000 and enter Young's increasing modulus. I've also talked about the increasing modulus in a previous tutorial. I'll put a link in the description box if you want to see it. So this means that if we put 500 into Young increasing modulus, the stiffness will increase by 500 kilonewton per square meter per depth. So let's start. It's 5000 and here we're gonna put it 500. Okay, so it's done. Now what is next? We're gonna define the structural elements. So first of all, we're gonna delete the volume. We're gonna decompose it into surfaces and delete the volume. So let's decompose it into surfaces. We're gonna delete this one, delete the entire volume and these two walls. I'm gonna intersect and recluster. So now we have the floor and the walls. So we should assign first of all a plate to these surfaces. So first of all, let's assign a plate. Create plate. I'm gonna create a plate here also and create a plate here. So this tutorial is very important if you plan on doing a building or any type of foundation for buildings, because it's like a real tutorial, so it's very important. So now we're gonna create two material properties for the plates. The first one is basement floor and the second one is basement wall. So we go to material, plates, new, gonna name it basement floor. Okay, so it's an elastic material. The thickness is 0.5 meter. Young's modulus is 3.4567. Okay, so the Poisson's ratio is 0.15. So it's set. You're gonna copy the material, name it basement wall. You're gonna change the color. The thickness is 0.3 here. Also, I didn't put the weight in the last material. I'll change it now. Okay, so everything else is okay. I'm gonna edit this one. It's 15. Okay. So first of all, I'm gonna assign the material, the floor, and here I'm gonna assign the walls, this one too. Okay, so now I've drawn the walls and the raft. So next we're gonna create a load on the walls. Okay, so we're gonna create a line load. We can create it on the head of the walls. So here we're not gonna put the value of the load, we're gonna put it in the stage construction. So here we're gonna create a beam. It will be our column. It will be on 660 and 66 minus 2. Okay, so it's 660 and 66 minus 2. So we've created our column. This is the column. Okay, so here we should create also horizontal beams. It will be on 0, 6 minus 2, 18, 6 minus 2, and these coordinates here. So I'm gonna create also two beams. First one is 0, 6 minus 2. The second point is 18, 6 minus 2. So these horizontal beam will help the load distribution in the raft from the column. I'm going to draw another beam. It's 6, 0 minus 2 and 6, 18 minus 2. So we've created the two beams. Now we should give them the material, assign a material to them. It's basement column and basement beam. So let's create these beams, new. So these are the properties of the beams. It's basement column. It's an elastic material. Young's modulus is 7 zeros. Its weight, volumetric weight is 24. This is concrete. So as you can see, when we put the volumetric weight for the walls, it was concrete, but it was much less than 24, because when we model a wall, it's plate and doesn't have a thickness in Plaxis, so it doesn't take off the dirt weight. So that's why we took it from 24 to 15 to take off the dirt weight. Okay, so this is the inertia of the column. We finished. we're gonna duplicate the material, basement beams. I'm gonna change the color also. I'm gonna add it. I'm gonna keep this one. As you can see, we've changed the volumetric weight for the beams since it's an intersection with the raft. So this is the problem with Plaxis. It takes both the material weight. Should put the inertia. Okay, so we're done. We're gonna assign the column. I'm gonna assign the beams. So we're done with the assignment. Now we're gonna put the load. So we're gonna put a load on the column. Okay, the column was 6, 6 and 0. So I've drawn two for a 2-point load. I'm gonna delete this one. Now we're gonna create a load on all the plate. Okay, so I think it's done for the drawing. Yes, now we're gonna generate a mesh, then go to the calculation. So let's generate the mesh first. Let's generate a medium mesh. It's the finite element mesh. So here we can see our mesh and the output menu. So this is the mesh, this is the structure, this is the column, and now we're gonna go to we don't have any water condition, we're gonna go to the stage construction. I'm gonna delete the old phase. Yes, delete. Okay, so now to the construction stages. Calculation type is K0. So we're gonna create phase 1, phase 2, and phase 3. In phase 1, we're gonna construct the wall and the excavation. In phase 2, the construction of the floor and the beams. And 3, the activation of the loads. So let's start. I'm gonna create first of all 3 phases. In this phase, we're gonna turn off the soil and turn on the walls. Okay, so not this one. I've turned on the walls and the excavation. So in phase 2, I'm gonna turn off the excavation also. I'm gonna put the raft and the beams also, so it's settled. For phase 3, I'm gonna turn on all the plates, the loads, the surface loads, and turn off the soil. So this is for the phases. I'm gonna check if we need to put something else. Plastic. Oh, so now we're gonna put the loads that are here. First of all, I'm gonna check the phases. It's plastic. Okay. So I'm gonna define the load in phase 3. So first of all, I'm gonna go to the point load. This is the value for the point load, the linear load, and the surface load. Let's start with the point load. It's minus 11650. So the reason it's minus because the z-axis is in this direction. The line load now, it's minus 385. Okay, so both line load were changed. And now the surface load, it's minus, okay, so if type something, it's minus 5.3. So I'm gonna define a point for the prescribed displacement, for the displacement curve, not the prescribed one. Okay, so I'm gonna choose this point here. I'm gonna launch the calculation. This may take a little bit of time. It depends on your PC, on the RAM of your PC, and the drive and everything. It's of course faster for NAS SD. So Plex is a great software for everything concerning geotechnical. I advise you to use it, especially for big buildings and special types of soil and special types of geotechnical construction. So this is a typical building. Usually they don't have beams, horizontal beams. So let's check the calculation. Okay. For the calculation, I'm gonna view the calculation. I'm gonna put a cross section in 06075. Okay. So first of all, let's check the output. So this is phase 3, phase 2, phase initial phase. There's no excavation. Phase 1, you can see there's an excavation and the walls. Phase 2, deflate, and phase 3, the displacement. So first of all, I'm gonna toggle off the loads so we can see our structure. This is the deformed mesh. This is the total displacement. As you can see, this is the displacement here. So first of all, we're gonna create a section. The coordinates were 0, 6, 0, and 75. Okay, so it's 0, 6, and 75, 6. We press on OK. This is the cross section. As you can see, it's the same value. So we can move the section by pressing on Ctrl plus or minus. You can see the deformation. Okay, so I'm gonna get back to here. Here you can see it's orange. When we come near the column, it becomes red. Here it's the maximum. Then it goes back to orange, then yellow. Here there's a low displacement until we go out of the basement and there's no displacement anymore. Okay, so now we're gonna see also the plate. So we're gonna double click on the plate and we get this. You can see the deformation. We're gonna go to the force M11 and we're gonna go to view, viewpoint, and top view. Apply. Okay, so you can see the moment its maximum here at the column, then it goes to negative to get to the wall where it goes back to positive. You can imagine the deformation here. It's close to the moment, as you can see it. So this is all for this tutorial. I'll be making more tutorials about dams. Uh, I'll make also about retaining wall, everything concerning geotechnical. So stay tuned and see you in the next tutorial. Thank you for watching.